How's it going? So today we're gonna take another step in my pursuit to not have to do anything at work. This is my cute little tractor. Everything's fine and dandy with it. It works just fine. The one problem I have with it, I have to stand up and walk around to control it. Ooh. So today we're gonna take that little guy and we're gonna make him remote controlled. So I spent most of the day yesterday designing this. And this is the dash of the machine. I don't know why I'm filming a screen. I think I just wanted to show off the monitor arm again. Here, let's put this there. I spent a good portion of the day yesterday designing this. This is the dash to the machine and all the little components that we're gonna use to remote control this thing. I'm fairly confident about the steering portion. The rest of it, no frickin' idea. I'm planning on using these little 60 kilogram servos, which sort of strong. I really don't know if this is gonna work. So the way we're gonna build this, we're gonna start at the parts that I'm most unsure of and move along. So hopefully we get all the big problems solved in the beginning. So first things first, gotta cut out a buttload of parts. We're gonna start with the part I have the least confidence in, and that is the bucket controls. For the most part, this is exactly how they're gonna go, but we gotta make these little arms. We got a little control arm thingy. This side just gets a little pivot point, so we can swing it back and forth just like that. And this side gets a little servo arm thingy. Now I guess let's pull the machine in. I took the controls off, so yeah, I just gotta go forward and back by pulling this. I got this guy to steer. Hopefully I won't have to steer that much. Safe. We got it in there with no casualties. This guy goes right here. I have a basically identical one that goes underneath that. Now, in order to control the movement, we got our up, down, and we got our left, right. Huh? You see? You see my line of thinking here? Anyway, let's install these. So here's the up-down arm, servo and all. I put the servo on backwards because, of course, the one part that I didn't include in the frickin' drawing interferes with the servo. Well, hopefully that's the only problem this will cause, but we got lucky in that. Let me squeeze this thing on here. Or we can install the servo facing inwards and still have enough clearance to pull this thing all the way down. So, yeah, lucky break. Either way, let's get this thing installed. Here's a big problem of having the servo on the inside is it is a frickin' pain in the ass to get these screws out. Ay, that is some toxic fumes. While that side cools, we can go ahead and do the same for the other axis. I'm tacking each of these with the same servo. That way, if this screws it up, I only screwed one up. Alright, I guess now we wait for all this to cool, reinstall everything, and I think I'm gonna wire it up so we can make sure it works before moving on. Yeah, I'll be right back. Ta-da! I got all of this reinstalled. You already know how that works. And I got all of this wired up here. Since this really is pretty frickin' dangerous, we've got a couple layers of safety here. This button turns on the Arduino and the small electronics. And we've got a relay and an e-stop. So right now, we still use the key on the machine. We can turn it on, but we've got both the e-stop, which will shut it off, engine and all, and this relay, which I have hooked to this this little knob. So if I switch that up, we can turn the machine on and off. And over here, we've just got our Arduino and our little RC transmitter. The Arduino is just reading what the RC transmitter gets from the controller, and we're gonna use it to interpret it to the various different types of controls that we have on here. Right now, it's just telling the servo what to do. So, let's give it a shot. Now, one problem I have is these controls are locked up until the engine is started, so we're gonna have to test this with the machine running, which I don't love that, but here goes nothing. It appears we have a problem. So I was wrong. This thing actually is kind of working. Just the servo horn on here wasn't properly attached, so it was kind of just swinging around. So, as you can see, we can control the bucket. Now, one little problem. So the problem we're having now is, one, it's a little harder to push this thing this way than it is that way. Two, we can't push this all the way down, but both of those are pretty fixable. I think we can fix this one in software. So it can't be fixed in software. It is a power thing. So we've got a couple options here. Either we need to get more amps to these servos. I seriously doubt that this little step down voltage converter is supplying as many amps as these things can use. The other thing we can do to fix it is add spacers or some kind of mechanical advantage. I think I'm going to start trying to fix the current. So instead I came in and temporarily wired in this Becc controller thing rather than this little step down voltage converter. And there, that's totally all it needed. Can you believe it? I did not expect that to happen. Well, I guess we'll start working on the drive mechanism. So, these two pieces have a little tab that sticks together, just like that. So we have our little piece there, and then we can add the cutest little gusset I've ever seen. That gusset kind of just turned into one big weld. Now then, we also have this piece, which just gets attached to a servo horn. So I went ahead and temporarily installed the horn and the servo on here, just so we can space things out properly. The end of this little lever is where this piece goes, and then we line it up right where we want it, and we can mark it with a drill bit. Now we can go ahead and drill and tap these holes. Now we just install this using some 3/8 bolts. And then this guy gets bolted on right here. If only I could find the nut for this. That might have to mean a trip to the hardware store for one nut. So, I'm gonna use this nut as a spacer so we can get this thing tightened on there. Just like that. Now one little problem I noticed is when it turns, it moves that a little bit. It kind of moves it a lot. Maybe we should just leave it loose. Frickin' janky as hell, but I don't know. I'll try it. So, yeah, that didn't work at all. I think I'm gonna wait for the hobby store to open and try and replace the servo just with a stronger servo and maybe figure out a linkage that's better than this stupid loose bolt. But they're not open yet. So we're gonna move on to the portion of this that I'm pretty confident is going to work. The steering. So the steering works by yanking this thing around, which I would show you if I was strong. So I'm gonna take this chunky boy off, and here I have a spacer, another spacer, and a gear. Can fasten this in place. Now we just need a way to stick a motor on it. So here's our motor. I've already mounted a little pinion on there, which is gonna mesh with that other gear. Now, this piece is our mounting plate, and in order to have easier access to the bolts, they're gonna go on the side, like that. So, these are going to bolt into these pieces, which will be welded on the machine. One little problem with that though, these are the little mounting pieces that I have cut out. I got them all installed on here, and putting those right where they belong, or you know, I assumed they belong. The angle is correct. Everything else is wrong. Right here is where the gears are meshed. So we are about a 1/4 inch off in both directions. So, kind of just gotta pull this out a little bit. I think that'll work. Okay, I got it fully welded on now. I swear to God that this Bobcat paint smoke is more toxic than regular paint. I feel funny, but either way, let's give it a test. No way this doesn't work, right? Whoop! Look at that. We got steering. We really only need to go like 1 turn per direction. So, yeah, I guess the next thing, we need this motor to know where it is. So we're going to do that with a little potentiometer. Now we got 2 options here. One is we have the potentiometer reading from this gear, which would be more accurate, or we have it stuck to the back of this thing, which would be more easy. And you know me. Wow, I think we got a fair shot at that working. I guess now we somehow need to make a piece inside of here that can index onto this potentiometer. So somehow stick a piece of metal in the middle or something. Okay, what about this finish nail? Wow, that's perfect. It's almost like I painstakingly spent 20 minutes grinding it down on the belt sander and almost lost a finger doing it. This'll work. Now we pop a teeny little hole in the side here. And then our nail can go in there. That's nice. Then I don't know, maybe we'll epoxy it in place. Alright, let's hope that works. Guess now we just gotta somehow line this up. Dude, that was like freaking perfect. I'm also kind of surprised that these holes line up. It's a good day, man. I got it fastened on there, and dare I say it, man? It almost looks professional. All right, I'm gonna wire it up, and we gotta figure out which positions on this potentiometer are the far ends of the steering. The idea here is that we can use this setup basically as a big servo. By coupling the potentiometer to the rotation of the motor, we can basically use the readout from the potentiometer as the motor position. Now we can give it a set point and turn the motor until our motor position matches the set point. Bam! That's a servo. Now all we gotta do is calibrate the motor so it doesn't turn past the limits of the potentiometer and break it. Easy, right? And it's broken. Oh God, oh God, oh God. Motherfucker. Alright, this is the last time, I promise you. There we go. I really constrained it so that I don't push it past the limits of the potentiometer, so these small movements are kind of exactly what we want. That's it! It's working! Well, there you have it. Steering. Now, am I gonna fix that horrendous whine? No, it took me forever to even get it to this point. So, that means time to fix this guy. There are times when you can engineer your way out of a problem, and there are times when you just need to buy a bigger motor. So, yeah, we got a bigger motor. Now this piece of trash can go, and we'll replace it with this piece of trash. Then we can install our new servo horn, and as luck would have it, or maybe as standardization would have it, our old horn extension from the other servo will fit on here too. So, pretty neat. Yeah! I think it works. Yeah, that didn't work as good as I thought it did. I don't know if you noticed. I certainly didn't. But this little BEC that I'm using to power this thing was smoking a little bit. Now, I don't know why this thing is rated for 10 amps and then has the tiniest little wires coming out of it, but I don't know. RC people are weird. We already put the big motor on here, so I guess to solve our problem now, we have to engineer it away. Ew. Work. So here we have some parts. And these parts are gonna make the most Dr. Zeus ass gearbox you've ever seen. So, let's get started. Alright, so the installation of the servo on here is not the most straightforward thing in the world. Actual step one is gonna be installing this little collet onto the face of the servo gear. Now, we install our servo horn. with our servo horn in place, we can come in here and painstakingly try and get it onto our servo. And then we have to install our center screw through here, which is it's not gonna be easy, man. Wow, would you look at that? It was easy. All right, then we just gotta finagle this thing into place. And it looks like our collet is too big. After much pain and suffering, I got it installed. All I had to do was cut the hole for the set screw in half. It's fine. We don't need a set screw. This collet is just to hold an 8mm shaft in a bearing on this side. So it's gonna spin on the most low friction, option it has. So yeah, I think we'll be fine. Plus I left a burr in there, so that's kind of gonna be like a structural burr. Like I said, shaft goes here. The only bearings I have are these bearings that I mutilated, so, whatever, it's fine. Alright, that actually doesn't seem too bad. Now, we got this gear, which gets some countersunk screws, just like that. Now, we take our little gear stack and install it up here with the, I don't know how well I can do this on camera, man. I've got performance anxiety. And lastly, we put this piece right here. Would you take a little look-see at that? Having the ability to make gears is such a frickin' game changer. It was definitely worth all the pain and suffering of building that new plasma cutter. Now there's a little bit of slop here. I thought there was going to be a little bit of slop between these two gears, but there really isn't, which may cause a problem, and it kind of feels like it gets stuck at this point. So, honestly, printing a new one of these gears is not the biggest deal in the world. Maybe I should just do that. Got a new gear on there. As you can maybe see, I offset it by literally like 0.01 inches, which that was just enough to mitigate any friction that was going on in there. So now, we are frickin' gearboxing well, man. Let's get this thing installed on the machine. Look at that thing, man. It looks good there. Now, we just gotta wire it up and figure out our limits again for both the offset from steering and the overall span of it. Otherwise, that's about that. All right, we're all hooked up and it all seems to be working pretty well. You probably can't see it, but the little thing on the inside, it's actually pulling that up and down, which is, it definitely was not doing before. So, there's nothing to do but to start the engine and give it a whack, huh? Oh God. This is a remote control Bobcat, take one. We're just gonna start it at half throttle for safety. That's very sketchy. I almost hit my truck a couple times. So I guess I just gotta work on it here on the sidewalk. The neighbors love me. Yeah, I was noticing this problem a little bit before. When the battery gets low, this servo tends to like to not home in the center. It kind of homes off to the side a little bit. So that's probably why it wanted to turn so badly. I mean, I probably drained the battery a decent amount testing it. I guess I'm gonna charge it all the way up. Hope that it doesn't happen again. If it does, we're just gonna have to put another battery in. But I would think that the alternator would be able to support all of this. I don't know, I guess these are taking quite a bit of current. Either way, I'll be back with a full battery. It's all charged up. Let's try and drain that battery. Can you believe it? That works so good. But there's two things that we need to improve. Thing one, this doesn't get pushed forward enough to lower the bucket. So that's just an adjustment in software. Thing two, the tilt down is still so slow because this is hitting here. So, beautiful. It's working so well. I guess nothing left to do but take it to work. I didn't like that at all. One more clenchy moment to go. Sorry, Street. Let's put this thing to work. Well, that was freaking awesome. Let's go somewhere with better lighting. Now, sadly, I gotta take all this stuff off so I can actually get some work done. It's not exactly safe. Full disclosure, there were a couple times where the bucket would get stuck or something, like when I was unloading it off the trailer. But otherwise, this thing worked pretty freaking flawlessly, and I think if we just got some better servos for the bucket controls, we'd be freaking cruising, man. And let it be known, if I ever get to a point in my life where I don't rely on these machines to make a living, we're doing Bobcat battle bots. So subscribe so I can do that. But yeah, that's what I got for you this time. If you like what you saw, leave a good old dinger. Think about subscribing, and thank you for watching.